In this video, we're going to take a look at the quotient rule for higher roots. So the quotient rule for higher roots: let the nth root of a and the nth root of b be real numbers with b not equal to 0. Then the nth root of a divided by the nth root of b is equal to the nth root of a divided by b. Simplifying radical expressions containing higher roots. 1. Use the quotient rule to write as a single radical. Simplify the radicand using laws of exponents. If helpful, write the constant and prime factors. 3. Simplify the radical by removing perfect nth powers from the radicand. And 4. Simplify the expression if necessary. And then simplified form of a radical. A radical is in simplified form if it meets the following rules. 1. The radicand does not contain any factors that are the perfect nth powers. 2. The radicand does not contain a fraction. And 3. There are no radicals in the denominator. So number 1, it wants us to simplify and assume the variables represent positive real numbers. In A, we have the cube root of 250 x to the 4th y to the 13th divided by the cube root of 2x to the 13th y to the negative 1. So the first thing it wants us to do is write it as a single radical. So we're going to have the cube root of 250 x to the 4th y to the 13th divided by 2x to the 13th y to the negative 1. And now we want to simplify the radicand. So we're going to have the cube root of, now we have 250 divided by 2 is 125. X to the 4th divided by x to the 13th is x to the negative 9 in the numerator, or x to the 9th in the denominator. And then we have y to the 13th divided by y to the negative 1, which is y to the 14th. And now we want to simplify the radical. So we have 125 is 5 cubed, so we have 1 5 outside of the radical. And now we have y to the 14th. 14 divided by 3 is 4 with a remainder of 2, so y to the 4th. And then we'll still have y squared inside the cube root. And the cube root of x to the 9 is x cubed times the cube root of y squared. In B, we have the 4th root of 81a cubed b to the negative 2 c to the 5th divided by the 4th root of a cubed b to the negative 10 c squared. So the first thing we want to do is write it as a single radical. So we have the 4th root of 81 a to the 8th b to the negative 2 c to the 5th divided by a cubed b to the negative 10 and c squared. And now we want to simplify the radicand. So we have 81 a to the 8th divided by a cubed is a to the 5th. B to the negative 2 divided by b to the negative 10 is equal to b to the 8th. And c to the 5th divided by c squared gives us c cubed. So we don't end up having anything left in the denominator in this question. So put it over 1, or I could have made my 4th root smaller. And now we want to simplify the radical. So 81 could be written as 3 to the 4th. So we have a 3. The 4th root of a to the 5th is a times the 4th root of a. So we're going to have one factor of a still inside the 4th root. And now we have the 4th root of b to the 8th is b squared. And we have c cubed. So we don't have the nth power of c inside the radicand. So we cannot take any c's out of the radical. So we're going to be left with the fourth root of a c cubed. And in c, we have the fifth root of 125 a to the 13th b to the 4th divided by the fifth root of a to the negative 10 b cubed c to the 15th, all divided by 5 squared. And we want to write this as a single radical, which is equal to the fifth root of 125 a to the 13th b to the 4th divided by a to the negative 10th b cubed c to the 15th divided by 5 squared. And now we want to simplify the radicand, so we can rewrite this as the fifth root of, now in the numerator we're going to have everything that's in the numerator, and then the 5 squared is all going in the numerator. So we're going to have 125 a to the 13th b to the 4th times 5 squared, all divided by a to the negative 10th b cubed c to the 15th, and that is equal to the fifth root of 125 times 5 squared. 125 can be rewritten as 5 cubed times 5 squared would be 5 to the 5th. We have a to the 13th divided by a to the negative 10 gives us a to the 23rd power. B to the 4th divided by b cubed is b divided by c to the 15th. And now we want to simplify the radical. So we have the fifth root of 5 to the 5th is equal to 5. The fifth root of a to the 23rd is equal to a to the 4th times the fifth root of a cubed. So we're going to have a cubed inside of our fifth root still. And since b isn't raised to 5 or more, we can't take any b's outside of the radical. And then we have divided by the fifth root of c to the 15th is c cubed times the fifth root of a cubed times b. And that's our video on the quotient rule for higher roots.